Welcome guys. Hope you're doing fine. Hope you're enjoying my videos. Do watch them. And guess which day it is? Yep, it's the 22nd of December. That means it is the birthday of one of the greatest mathematicians in all of history, Srinivas Ramanujan. Our country, or India, has made this day its National Math Day to celebrate this math prodigy. He has discovered around 3,900 or even more formulas, and you won't believe it, but they're even used to study black holes, neutron stars, and all sorts of astronomical bodies, which are very interesting. So let us also celebrate his birthday or his birth anniversary by learning about a few of his interesting, important formulas. So the first one is the infinite series of pi, which gives the closest, most accurate approximation of pi. It is basically pi itself. So we have the reciprocal of pi is equal to 2 root 2 by 99 squared into the summation of the infinite summation, because it starts from 0 and goes to infinity. So we have the infinite summation of 4 and whole factorial into 1103 plus 26390 into n divided by n factorial whole power 4 into 396 power 4n. So this is the formula. And just by taking the first term, that is by substituting 0, you get 8 of its first digits. And that's what's been done here, exactly. Because you'll have 1 factorial into, this turns out to be 0 because n is 0, and then you just have 1103 and then 396 power 4n. This also becomes 1. This becomes 1 because 4 and 10 is 0. So basically, you'll be taking the reciprocal of it, of this part. So you have 9801 by 1103 into 2 root 2, which is basically root 8. So that's the formula to give you the first 8 digits of pi. And till date, you may not believe it, but computers still use this formula to calculate trillions of digits of pi. Moving on to the next formula. The Ramanujan's partition formula, which is very common and useful. Sorry for the blurry image here, but I hope it's still legible. So we have the infinite summation of partitions into a complex number, complex variable, whole power n, and this is equal to the infinite product of the reciprocals of 1 minus q power k. And as you can see here, Pn is the number of partitions of n, and q is a complex number which can be expressed as e power 2 pi into I, which is root minus 1, into tau. Here, tau is a complex number, again, which is on the upper half of the Gaussian or complex plane. That is, its imaginary part is greater than 0. As you can see here, the point q, if you express it as a complex point, it lies within the unit circle on the Gaussian plane. That means its magnitude or modulus is less than 1. So this is the formula. So let me explain this with a simple example. Take the number 4. I'm not going to be using the formula here, but to make a partition, you'll have to write or make out subsets of integers, rather natural numbers, you'll have such that the sum of the subset is the number you want. So basically, in the subset, the natural numbers should be in descending order. So let's see how it works. Descending order also means that two numbers can be equal to each other. They'll just be placed next to each other, okay? So here's how it works. Let's take the number 4. You can write it as just 4, or 3 plus 1, or 2 plus 2, or 2 plus 1 plus 1, or 1 plus 1 plus 1 plus 1. If you noticed, I did split it into subset of natural numbers in descending order. So that is how you define a partition. And that is how you do this. This is basically the formula for much larger numbers. It used to take weeks for mathematicians to find partitions for, or the number of partitions for a very large number. But thanks to this mathematician's formula, we can do it within minutes. So these are his two formulas, and let's talk about one of his favorite numbers. So as the story goes, while Hardy, or Godfrey Hardy, was going to visit Ramanujan in the hospital, unfortunately he was hospitalized, he saw taxi number 1729 and he just thought it was some boring number. And then Ramanujan had to explain him that, it was a beautiful number because it could be expressed as the sum of two cubes in two ways. That is 10 cube plus 9 cube and 12 cube plus 1 cube. You can prove that out later. But since then, this number has been called the Hardy-Ramanujan's number. It is the smallest such number which can be expressed like that. The next number is 4104. So these are some of his discoveries and inventions. Hope you enjoyed this video. Happy National Math Day. Bye bye.